We all at some point encounter a problem when we need to alter the details of some functionality based on runtime data. For example, an object should behave a bit differently, values should be computed in a different way. Yeah, let's see how to elegantly solve such problems. Let's first make an example illustrating one such problem. Let's say we have a report class which holds a vector of values. Here is our imaginary report class. As you see, it's not much, just a placeholder. Report, and let's give it some values. 1, 2, and 3. Done. Now we would like to draw a graph of those values from the report. But we also want the type of graph to be configurable. So let's make a draw graph empty method for now. Draw graph. Okay then. And now let's call our imaginary report drawing. Report draw graph. Now how to make the draw graph method configurable? First, let's see how not to do it. Unfortunately, this is how I often see programmers solve this kind of problems. Let me introduce you the way of using enums and giant switch statements. So let's define an enum representing our graph type. Remember, this is how we should not do it. And for example, let's have a line and the bar graph. What we now need to do is to pass this graph type into the method, and now we have our switch statement which will do something based on our past graph type. And in the call, let's refactor it a bit. In the call, let's pass, for example, a line graph. So what are the problems with this code? For one, the graph type is tightly coupled to the report. Even if this enum was outside the class, it would still be tightly coupled because it sits right here in one of the methods. In fact, the report class takes the responsibility of drawing every possible type of graphs in our switch statement here. Also, note that there is no way to add new graph types without modifying the report class itself. If we add whatever graph type here, we would need to go into the drawGraph method and add another switch statement. This makes our graph drawing code very much non-extensible, well, or at least very hard to extend. In time, the drawGraph method could boil down to a giant switch statement. Fortunately, that's where the strategy pattern comes in. The pattern dictates that a generic functionality should be configurable at runtime by providing objects implementing detailed functionality. In our case, the generic functionality is drawing graphs from our reports, and the details are the ways the graphs can be drawn, line, bar, or whatever. So now first, let's get rid of this awful code here. Let's get rid of this enum, we don't like it, and let's start clean. So our first step is to create a graph drawer interface which will implement our concrete graph drawing classes, line graph drawer and bar graph drawer. So graph drawer, which would have only one public method, draw graph from our values, and we need two subclasses. Here we go. So the details how to draw a graph are now contained inside two separate classes in their drawGraph methods. The next step is to pass the appropriate drawer to the report to actually draw the graph. So in our report drawGraph method, we will simply pass graph drawer. And in our call, let's for example pass our line graph drawer. In reality, you can pass anything you want at runtime. As for the drawGraph method itself, we simply call the drawGraph of the drawer, passing our values. And now we can see how things come together. We decoupled the report from the graph drawing, which is contained here, and we instead passed the appropriate drawer at runtime. This way we can freely add new graph types without ever touching the report class. The class became configurable and the graph functionality in total became more extensible with low cost. This pattern is so useful, you are probably using it without even realizing, just by using the standard library. For example, let's look at our good old shared pointer. A shared pointer has a configurable deleter which you can pass to it at runtime to configure how the memory should be freed. For example, using the default deleter, which simply calls delete, we simply need to create the default shared pointer without passing anything. But if, for example, you would like the memory to be freed in a different way, because let's say the memory was allocated from a standard C function, then you can pass your own dedicated deleter, which will be used by the shared pointer. So let's see how our custom deleter can be used with our standard C memory management. We can use static cast to int pointer from a std_malloc call. Size of int. And now let's pass our standard 3 as our custom deleter. So now at runtime we configured our shared pointer to free the memory in a different way than default. And this configurable memory freeing is an example of a strategy. The shared pointer is responsible for managing the object lifetime, but the details of low-level memory management are left to the provided deleter. It's just like a manager in real life delegating work to specialists instead of micromanaging himself. We can also see the same pattern emerge on example our good old standard sort. You can specify both the execution policy and the compare functor, thus making the algorithm configurable without the need to modify it. So let's recap. If you have some high-level functionality like drawing graphs and you want to configure the details like how to draw a graph, use the strategy pattern by supplying the high-level algorithm with objects providing the low-level details. So I hope you know how the strategy pattern works. I hope you will use it where appropriate. Give thumbs up, like this video, click subscribe, and I see you in the next one. Peace.